So today what we're gonna do is learn how to do reflections, rotations, and translations. Oh, and I forgot to have you guys do the bell ringer.
Oh,
dang
no.
it.
It's okay.
Alright, we won't worry about it, but make sure you close your MacBooks, guys, okay? Okay, so what we're gonna do today is a transformation. All of these are in a class called transformations, but like I said, we do reflections, rotations, and translations, okay? One of the things you're gonna see today, or you could see today, is something like this, okay? And order matters. So if A comes first here, A would map onto X there. If Y comes second, it would map onto Y there. And if C comes last, it would map onto Z there, okay? All of these are called rigid transformations, and what that means, see you later, is that when you're done, like you take a figure and you rotate it, or you reflect it, or you translate it, both of your figures should be congruent. Do you guys know what that means?
The same.
The same size, same shape, okay? If they're not, that means you've done something wrong. And then again, these are called isometries because of that. So they both should be the same size, same shape. So here's the three we're gonna do today, and there's actually a whole chapter in our book on reflections, translations, and rotations. But due to all of what we have to teach you guys in 2 trimesters, it's a chapter we don't do it, and instead we just do all 3 of these today. And then, did I give you guys the right notes?
No.
They're not the right notes?
No, these are
Yeah, I was like.
Oh, you know why? I just didn't give you the first page. That's why.
Oh, that's right.
Yeah, sorry. So sometimes if there's a page with no problems, I don't print that. So that's why, sorry about that. So anyway, the first one is a reflection, and a reflection always has a line of reflection. And if you folded this on the line of reflection, A and F would match up, B and G would match up, and C and H would match up. Today, our lines of reflections we're going to use are the x-axis, which hopefully you guys know is this way, and the y-axis, which is this way, okay? The second thing we're gonna do today is a translation. A translation is taking something and sliding it, okay? You can slide up and down, you can slide left to right, or you can slide diagonally. That's what happens most of the time, okay? And then rotations usually take a long time, but we don't do rotations by hand in this class. Hopefully you've done them in a class before, but the rotations we do today is just gonna be one of them, and it's gonna be a very specific one. But a rotation is taking a figure and turning it, okay? So reflection is when you flip it over. Translation, you don't turn it at all, you just slide it. And a rotation is turning it. So if we look at this, now this page you should have in your notes. This just asks us, is this a rotation, reflection, or translation? What is this first one? A rotation. It's like turning it. Very good. And then if we look at our second one, what does that look like? Reflection. This was reflected over the y-axis, and if you folded that in half, it would map onto each other. Okay, how about the third one? translation, all they did there is they slid it, but you can't use the word slide, you have to use the proper name, which is translation. Okay, how about D? Reflection. Can you tell what it was reflected over? X-axis, very good.
Oh yeah, I did.
Okay, then if we look at E, what do you guys think of that one?
Rotation.
A rotation, yep. Okay, then if I look down here, what does this one look like?
Oh.
Translation. It was just slid over, so it is a translation. Okay, now if we go to this next page here, all right, it says refer to the pictures below and identify the type of congruence as a reflection, translation, or rotation.
Okay,
So-
put this one on.
What if you went from here to here? What does that seem like? It's a rotation. And a rotation is always about a point, which in this case it's here, and it's always so many degrees. So this one is a rotation. Okay. What if you had a vehicle that had a sliding door? What would that be called? Translation, good. And then what if you had footprints and your footprints in the sand? What would that be like? Reflection, very good. Okay, now you guys should have a cheat sheet that I handed out on Friday. Okay. Thursday, correct. Thursday. Yes. So you guys, the front side had the area and circumference and perimeter formulas, okay? The back side we'll do tomorrow, but yeah, this formula sheet right here.
Yeah, yeah. Yeah, don't forget you guys.
So today, we are going to take down some notes on reflections, translations, and rotations. And what I'm gonna have you guys do is add them somewhere on that cheat sheet so that you only have that one, okay? So the first thing, when you reflect over the x-axis, and remember this is x, okay? What happens if you look here is you change the sign so what I'm going to have you guys copy is this whole thing and put it somewhere small on your cheat sheet so you have it. You change the sign of your y coordinate. So everything I have circled there, if you want to put that somewhere on your cheat sheet. And then we're gonna do, we're gonna end up doing notes for this, for rotations, and for translations. And if you get done with that one, you can start copying this one. did everybody have enough time to do both of these? Okay, one thing I want you to notice is if you're reflecting over the X, you change the sign of the Y, so the opposite one. If you're reflecting over the Y, you change the sign of your X. So the opposite one is the one that you change your coordinates of. So another thing that I did not talk about yet is when you plot these, you're gonna plot your original figure and your new figure, okay? So if A is your first coordinate and you're gonna make a new A, here is what they do. They do A with an asterisk and it's called A prime, okay? Then B would be called B prime. C would be called C prime. Now, when you're looking at this, you have to look at which axis are we reflecting it over? We're reflecting over the X. So which of our coordinates is going to change? If we're going over the X, the sign of which one changes? Y. So when I do this, my X is going to stay the same, my Y changes. My X stays the same, my Y changes sign. My X stays the same, my Y changes sign. Okay? Then what we have to do is we have to plot both these original points and we plot our new points. Okay? So when you come over here, let's plot the original A, B, and C. So A is over 3 up 2. B is over 2 down 2. And C is over 1, 2, 3, 4 down 5. 1, 2, 3, 4, 5. Now you're going to combine those points and it should make a triangle. Try to do as straight of lines as you can. And I do have rulers up here if you would rather be more precise. Now, we also need to label the points. So the point 3, 2, I'm going to make it A. 2, negative 2 is B. And 4, negative 5 is C. So that's my original figure, okay? Now, what I'm gonna do is I'm gonna explain to you guys how to do this without using that rule. And then, yeah.
If we change the sign of the core file from Y to
I plotted these points.
oh, you're still counting it in.
Yeah, but if you plotted the others, you're gonna end up doing that, so you don't have to erase it. I'm gonna show you guys a second way to do this if you would rather not use the rule, and then it's up to you which one you use. So we're plotting over the x-axis. So if I look at my A right here, what I can do is count straight down how many spots above the x-axis your A is, and it's 2. So then you'd go 2 in the opposite direction, and you'd label that A prime, okay? Then for B, notice B is below the x-axis. So what I have to do for B is count up. And if I count up, it's 2 away if I go straight up. And then I go 2 in the other direction, and that's B prime. And then for C, it's 1, 2, 3, 4, 5 below. So then I go 5 up. 1, 2, 3, 4, 5. And that is my C prime. And then when I'm done, I connect the dots. Okay? And what you would want to think about, if you took this and you folded it on the x-axis, do you think your C's would line up, your B's would line up, and your A's would line up? And they would. Which of those two formulas you use, it doesn't matter, or which of the two rules. But when I grade this, you have to have both figures drawn. One of them A, B, C, the other one A prime, B prime, C prime. Okay? Now this one is over the y-axis. Okay? So if we do the rule that I had you guys write down, okay, which of our coordinates change signs if we're going over the y? Yes, we're going to change our x's this time. Okay. So our x changes, so 3, 2 is going to become negative 3, 2. The b is going to be negative 2, negative 2. And c is going to be negative 4, negative 5. Now if I go to plot the first A, B, and C, A is over 3 up 2. The A, B, and C are the same as up above. B is over 2 down 2. And C is over 4 down 5. Okay, and then you have to label those A, B, and C, and then connect the dots. Okay, now if you like doing the rule, you guys, you can just plot these three and connect them, and then kind of check that they look correct. If you want another way to do it and not use that rule, this time we're reflecting over our y. So if I start at A and I want to reflect over y, I'm going to go straight to the y and I'm going to count how many spots away I am. And I'm 1, 2, 3 away, so then I go 1, 2, 3, and that is my A prime. B, I count straight across to the y and it's 2 away, so I go 2 in the other direction, and that's B prime. C is 1, 2, 3, 4 away, so 1, 2, 3, 4, and that is my C prime. And then I would connect those. And if you were on a quiz and you did both ways, you could then check, is A at negative 3, 2? Is B at negative 2, negative 2, and so on. Everybody understand reflections? Is that easy? Okay. Now, what I'm going to do is have you guys copy this somewhere in your notes on that note sheet. So you'll probably see you want to try to write small. Did you guys watch the Packer game at all yesterday?
Yeah, so
That was awful.
made me happy.
Did it?
Yeah, it did.
And the Vikings won, right?
Yep.
Obviously.
Dude, this was her first time this season.
That's the first time.
What if the Packers played the
Well, like, it's
Vikings?
exciting.
Do you think the Vikings would
Yeah,
win?
we won that all.
Against the Packers?
Yeah.
It'd be close.
No, we-
And then, did anyone watch the Badgers game? The Badgers are so bad this
What
year.
is the Badgers?
What?
What is the Badgers?
It's the new team. in the NFL.
No, no, no.
Oh,
Wisconsin Badgers.
Like
The college.
oh, the
college
oh.
football.
are you from Wisconsin?
I am.
Yeah, Brandon, that's a new team that I have.
It's okay.
All right, did I give you enough time?
Maybe.
You can use this note sheet on the test. Good question. Yep. All right, but you can only write on the note sheet what I tell you to. Okay? All right. So the next thing we're going to talk about today is something called a translation. And you'll see the words here, vector notation for a translation. What they mean by a vector, you guys, is they're gonna give you 2 points in these arrows, one pointing to the left, one pointing to the right. This one might be -2 and this one might be a +7. And what those two numbers are telling us is where to move our points, okay? So here's the deal. The first number tells us where to go left or right, just like if we were graphing a point. And if it's negative and we were graphing a point, wouldn't we go 2 to the left, right? Do you guys get that? And if it's a +7, we'd go up 7. The only difference with vectors is instead of starting at the origin, you're gonna have a figure and you start at each of the points of the figure, and then you would go, like in this case, if this is positive, you go 2 to the right. This is negative, you go 5 down. So this is exactly what you would think of as you were graphing. If your first number was positive, you go to the right. If it's negative, you go to the left. If the second number is positive, we go up. Second number is negative, we go down. So the only difference is you don't start on the origin here. You would have points on your figure that you would start on. And let's go and do one of those and then I can explain it. So let's go to example 4, and it says, for quadrilateral QRST with these vertices. So Q is -7, -2. 1, 2, 3, 4, 5, 6, 7, -2. We put a Q. R is -8, -5. -8 is all the way out, so down 5 from that. Okay, that is our R. S is -4 and then down 7. 1, 2, 3, 4, 5, 6, 7. That is our S. And then T is -4 down 2. That is our T. So your first figure should look something like this. Okay? Now, you always have to look at what vector you're moving things. Okay? So, if you have a +7, you always go left or right first. Which way do you think I'd go?
Right.
7, right? And if 1 is positive, which way would I go? Up 1. So from every point, you guys, you count 7 to the right and 1 up and put your new point. So Q, if I go 1, 2, 3, 4, 5, 6, 7, 1 up, that's my Q prime. T, I go 1, 2, 3, 4, 5, 6, 7, and up 1, that is my T prime. R, 1, 2, 3, 4, 5, 6, 7, 1 up, that is my R prime. And for S, 1, 2, 3, 4, 5, 6, 7, that is my S prime. Then you would connect these. They should look the exact same size. And it should just be moved like 7 over and 1 up when you get done. Does yours look like mine? Okay. All right, now let's try one more of these. This time we're gonna plot the points. M is at -2, 3. So we go left 2, up 3, that is my M. Then N is left 4, up 6. That is my N. And then P is left 1, up 8. That is my P. Okay? Now, when I go to connect this into a triangle, it's going to look like this. All right? And then what we have to do is we have to move things along this vector. If it's a +2, which way do you think we're moving things? to the right. And then if it's a -3, down. So for every point, we're going 2 to the right and down 1, 2, 3. And that's gonna be our new prime. 2, or for n, if I go 2 to the right and down 3, notice my new n maps right onto my m, and that's okay, that happens sometimes. And then my m, if I go 2 over and 3 down, that goes right here. And then when I make that new figure, that is what it looks like. Is that okay? Everybody understand translations? Not too bad? Okay. All right. Now if we go to this page, I was telling you guys at the beginning, when you do rotations, usually we spend a day or two in class, and it's one of the things that we stopped doing because we just can't get to everything that we want to. So when we do our rotations, we're only gonna do one specific one. So here's what I want you guys to do. Copy, when you rotate a point 180 degrees about the origin, I'm gonna change this, because I think what I'm gonna do is rewrite this as switch the sign of your x and y. Okay. So this is just for 180-degree rotations. Okay. So, this works whenever you are going to rotate something 180 degrees about the origin, okay? And what it says is when you do that, you're gonna take both your x and your y and the point, and you're gonna change the sign on both. So let's look at this first one. And this first point f is over 2 up 1, so that's my f. G is over 7 up 1, so that is my G. H is over 6 down 3, that is my H. And I, or no, is that a J?
J.
Is over 1 down 3. Okay? So we are gonna plot that original figure. All right, now what we're gonna do is figure out what is gonna be our F prime, our G prime, our H prime, and our J prime, okay? And if you look at what I had you guys write down, you're gonna switch the sign on both your X and your Y. So if F is 2, 2, the new one's gonna become -2, -1. Switch both signs. G is gonna be -7, -1. H, 6 is gonna become -6, -3 is gonna become +3. 1 is gonna become -3, or I'm sorry, -1, and -3 becomes +3. And then we're gonna plot those points. So we're gonna go -2, -1, and put a F prime there. G is at -7, -1, so we're gonna put a G prime. H is at -6 up 3, so that's our H prime. And J is at -1 up 3, that is our J prime. So we will connect, and that is what you should have. Does that kind of look like what you guys have? Okay, and make sure you label the points. Okay? Everybody good? All right, down here, let me just talk about this super quick. What do you guys think this is? A reflection over what? Yes, very good. What about the second one?
Transition.
Translation? Let's see. What do you guys think about that one? I think it is a translation. It just took it and kind of slid it.
Yeah.
So translation, good. All right, so when I show you your assignment, some numbers are listed twice because what I'm doing is showing you which ones have to be graphed. Okay, so this is your assignment. By the way, don't worry about 18 because kids ask me about that one all the time. Don't worry about this one. And then, so some of these are repeated down here, but I'm just explaining this to you. These are the ones that have to be graphed, okay? When you're done, you should have 1, 2, 3, 4, 5, 6, 7, 8 things graphed. I'm gonna give you one sheet of paper. If you don't have all 8 things graphed when you're done, that means you did something wrong. Okay? All right, and I will hand out one sheet of graph paper to everybody. How did you guys think it was today? Hard, easy?
Yeah. I bet it's dangerous.
And then did you see on the board that you have a test this week on Friday? So it'll have what you had on your quiz plus what we've learned since then.
Thank you.
Oh, did you actually, that was actually translation. Transition?
It's a transition, like, it's right.
Sorry,
It's
transition.
right.
Transition.
It's a transition into the freaking XY.
Yes, oh.
Did everybody get graph paper?
Yes, ma'am.
I think she has one. Here, I got an extra.
That's just a transition.
Really? Really throw math text. Are we serious?
Miss Martin, do you think we get to, or will we get to use our notes from our last quiz on this
Yes.
one? Oh, okay,
Yes.
perfect.
Yes.